Welcome back to my statistical method class. So, for today's class, we will discuss on how to describe your data using numerical measures. So, I hope that everyone is ready to learn something new. So, this is the overview of Chapter 3. In Chapter 3, we will discuss on the measure of location. There are actually a few types of measure of location. So, we will focus on arithmetic mean, which specifically discuss on the population and sample, and then we will discuss the median, mode, weighted mean, and geometric mean. We'll also discuss the measure of dispersion. We have range, variance, that can also focus on the population and sample, as well as standard deviation. So we will talk about Shaft Theorem as well as Empirical Rule. So the last one, basically this is under chapter 4, but I will just put it here because we will cover a very short brief on the skewness using Pearson coefficient. At the end of chapter 3, I'm expecting my students to be able to achieve this learning objective. So what are the learning objectives? So you should be able to compute and interpret the mean, which is arithmetic mean, median, mode, weighted mean, geometric mean, range, variance, and standard deviation. You should also be able to explain and apply Shaft Theorem as well as the empirical rule. Okay, so remember, in this chapter, I also included one portion or one part of chapter 4, which is skewness using Pearson coefficient. So you should be able to also compute the Pearson coefficient. And the last learning objective will not be covered in my session. So what is measure of location? It is often called as average. It is a value that used to describe the central tendency of a set of data. In other words, we want to know the central value of the data set or the center of your data distribution. So there are common measures of location. We can use mean. When I say mean, it refers to the arithmetic mean, and you can also use median and mode. But normally, arithmetic mean is the most widely reported or used as a measure of location. At this stage, you should be able to distinguish what is population and what is sample. So from my previous discussion, I have mentioned to you, population refers to the entire set of individual or object, while sample is just part of the population. So in this slide, we want to actually compute the means of your population. Okay, so let's look at the formula for population mean. So if you look at here, you can have mu. What is mu? Mu normally refers to population mean. So it is equals to summations of x. So what is x here? X is actually the observation. So summations of all your observation divided by with capital N. So what is capital N here? Capital N refers to the number of people in the population. Okay, so any measurable characteristics of your population is called as parameter. So when you have computed the mu, so you have summations of x over n, so you will get perhaps equals to 5.1. So this 5.1 is called as parameter. So what is this parameter? Parameter is just a characteristics of your population. Let's look at the example on how to compute your population mean. So there are actually 42 exits on the I-75 through the states of Kentucky. Listed below in the yellow table are the distances between exits in terms of mile. Okay, so if you look at here, you have 42 exits. So what is this 42? This is your observation, or we call it in statistics your x. Okay, so if you want to count it, 11, 4, 10 until 1. So where is my cursor? Until 1. So if you count them, the value is actually equals to 42. Okay, so let's look at the question. Why is this information is called as your population? Remember, you should be able to distinguish between population and sample. When we talk about population, it refers to the entire sets of individuals or objects. Since in this case, you only have 42 exits in the states of Kentucky. So you are taking into account all the exits in these states. Okay, so that's why it's become your population. But let's say if let's say the information given to you just this exit, so from 11 until this value 11 until 5, so you can see this, it is just part of the population. When you talk about part of the population, you will call this your sample. I hope that it is clear to everyone. Second question, so what is the mean number of miles between exit? So at this question you are asked to compute the mean of your population, because you know that this information are considered as your population, so you are asked to compute the population mean. So what is the formula for population mean? If you still remember in the previous slide, the formula to compute population is mu equals to summations of your observation, or your x equals to the whole number. So how to compute it? So summations of x, so you have the first observation 11 plus 4 plus 10 plus all this number until 1, and then you have to divide it with your n. What is your number of observation? You have the total number, which is 42. So when you compute it using your calculator, you should be able to get the value of your population mean, which is 4.57. Okay, so this is the answer, as simple as that. This slide is telling you the answer for my previous question. So if let's say some of you are still unclear, so I have somehow included all the answers for your easy reference. Okay? You have learned how to compute your population mean. At this slide, you will learn how to compute the sample mean. So basically the formula is very similar. In your population mean, you will see this mu, but in the sample mean, you will see this term, x bar. So you will see this x, on top of it you have a small line, you call it bar. So the formula is summations of x. So what is x? X is actually your observation, and summations of x divided with your n. So in the population mean, you will see the capital N, but here you will see a small n. So capital N to represent the population. So you have a large number of people, so you will use capital N. But because we are talking about sample, it is just part of the population, so we will use a small n to differentiate between population as well as sample. Okay, so any measurable characteristics of your sample is called as statistics. It means that when you have computed this, your x bar equals to summations of x divided with n. When you got the value, for instance, you got 2.5. So this 2.5, you call it as statistics. But if you compute for the mean, I mean the population mean, so when you compute it, you will call the value equals to parameter. So you should be able to distinguish what is parameter, what is statistics. So statistic is just a characteristics of your sample. Let's look at the examples on how to compute the sample mean. So basically, if you know how to compute the population mean, it is basically easy for you to compute the sample mean, because the formula are very similar or exactly the same. Verizon is studying the number of minutes used by clients in a particular cell phone rate plan, a random samples of 12 clients. So remember, this is your sample. It is mentioned that samples of 12 clients showed the following number of minutes used last month. So you have 90, 77 until 83. So you have 12 clients here. So what is the arithmetic mean number of minutes used? So how to compute your arithmetic mean of your sample? So the same formula, you have summations of x divided with n, small n. So you have to sum 90 plus 77 plus 94 until 83 divided with your 12 client. Okay, so you should get the value of 97.5. So what is this 97.5? You will call it statistics. Properties or characteristics of arithmetic mean. So I know that you know how to compute arithmetic mean, but you should know what is it actually. So if you want to compute arithmetic mean, your data should be interval or ratio scale level of measurement. Why is that? If let's say you have nominal or ordinal, you cannot compute arithmetic mean, because ordinal and nominal only classify the variable into a few groups. So the group has no value or no number. So you cannot compute their arithmetic mean. Only intervals and ratio can have the value. So that's why you need at least interval or ratio. Okay, the second characteristics of arithmetic mean is that all the data will be used in your calculation. For instance, you have 12 samples. So all the 12 samples will be used in your calculation to compute the arithmetic mean. And the next one, arithmetic mean is a unique. So what is unique actually? So unique here means that when you compute the arithmetic mean, you will only get one value. You shouldn't get 2 or 3 values. You will only get one value. That's why you call it unique. So the next one, the sums of the deviation from the mean should equals to 0. So in statistics, we will write it the sum. This is summation of x minus the mean. So sum of the deviation from the mean. So your deviations of observation from your mean should equals to 0. So let's take an example. So the means of these three observations, so you have 3, 8 and 4. So the mean is equals to 5. So you know how to compute the mean, right? So 3 plus 8 plus 4 divided by 3, you should get the means of equals to 5. Okay, now try to apply this formula. So the summations of x minus the mean should equal to 0 if let's say you want to use arithmetic mean. So this is your first observation, which is 3. So 3 minus the mean, which is 5, plus. Why do I have to put plus? Because it is the summation here. So plus 8, second observation, minus your mean, 5, plus 4 minus 5. So in total, you will get the value equals to 0. Right? So this is the characteristics of your arithmetic mean. However, the last point tell you the weakness of using arithmetic mean. What is the weakness? Even though it is most widely used by statisticians and also researchers, but arithmetic mean has a weakness. The weakness is that mean is affected by extreme values. Okay, let me give you the example. If let's say you have two persons, let me see, where is my cursor? Okay, here. So you have two persons, person A and person B. So person A got an income of 999, while person B got an income of $1. Okay, so if you want to use the mean to represent, to tell about the average of these two persons' income, so how can you compute the mean? So you will compute summations of x divided by n, isn't it? So you plus these two values. So 1990 plus 1, you will get equals to 1000. And then when you divide by the two people, you will get equals to 500. So can you say that on average, each person will get an income of 500? So basically, when you have an extreme values, one is too large, one is too small, you cannot use arithmetic mean to represent the average, to show the central value of your data. Because if you have an extreme value, your result, your descriptions of your data will be very biased. Okay, in this case, you can see that it is almost impossible to say that person B which get an income of $1, and then in your interpretation you said that, well, on average both of them will get 500. It is wrong. So in this case, you shouldn't use arithmetic mean. So what types of methods should you use? We will see it in the next slide. If you are dealing with the extreme numbers, means that you have such a very small number as well as such a very large number, you know that you cannot use the arithmetic mean. But you can always use the median. So what is median? Median is the midpoint or middle numbers or values after they have been ordered from minimum to maximum. So you can also look at it from maximum to minimum. They are the same, but you have to order them. If you look at here, you can order from the minimum, which is 60,000, up to 275,000, or you can also start from the maximum, to the smallest number. But normally it is easy to order them from the minimum to maximum. And then you will pick the middle point. Okay, so this is the case of an odd number. What do we mean by odd number? If you compute your observation, you have 1, 2, 3, 4, 5. So you have 5 observations. So you can choose the middle, which is observation number 3, right? But if let's say you have an odd number, instead of 5 observations, and you can choose 3, you have 4 numbers. Let me give you one example. So the example here is, let's say you have, let me see, where is my pointer? So let's say you have observation number 3, observation number 6, observation number 7, and 4. So you are asked to compute the median. So how to compute it? Should you take which value? Because you cannot determine which one is the middle value. So what you can do is, first you have to rank them. You have to order from smallest to largest. So which one is the smallest? You will start with number 3, and then you will start with number 4, and then number 6, and last one is 7. So because you have odd number, so you will take the middle 2. So 4 plus 6 divided by 2. What will you get? You will get 5 as your median. Okay? Characteristics or properties of your medians. So medians is the value in the middles of your sets of data after you have ordered them. So at least you need an ordinal scales of measurements if you want to compute your medians. Okay, so why is that? So for ordinal, let's look at the examples of the teacher size. So you have small scales, you have medium scales, as well as large scale. So in this case, after you have ordered the group, you know that in the middle is your medians. So how about the nominal scales? So for nominal, you know that you just classify your variable into groups. For instance, gender, you have male and female. So which one is the middle? You don't know because they don't have their order or rank. So you cannot use median. Okay, and then it is not influenced by extreme values. So this is the advantage of using medians, because regardless of how large the values in your datasets or how small the values in your dataset, it doesn't matter because you will just pick the middle point. Okay, the next point, this is how you interpret your medians. So you can say that 50% of your observation are larger than the medians. Okay, for instance, you have computed the medians. Okay, so you have how many observations? Maybe 5. And then after computing the medians, you got the medians equals to, for instance, 10. Okay, so how you want to interpret this number, this median? So you can say that 50% of your observations are actually bigger or larger than 10. Or you can also say that 50% of your observation are smaller than 10. Why it is bigger or smaller than 10? Because you know that median is the middle point. So 50% here are smaller than your 10, and 50% here are larger than your 10. Okay, so the last one, it is unique to a set of data. It means that you will only have one value. If you compute the medians, you will just get maybe 10 or whatever, just one value. That's why you call it unique. This is actually, well, another examples on how to compute your medians. So I believe that you know how to compute it, and please try to compute it at home. Okay, we have covered the arithmetic mean, median, and the third measures of location is known as mode. So what is mode? Mode is actually the value of your observation that are most frequently occurs. So in these examples, you are given various bus oil. Okay, so you want to know which one is the most frequently occurs or preferred. So you can see here you have Lamore. Okay, so let's look at the characteristics of this mode. The mode are normally useful for a nominal data, because in the nominal data you don't have any rank, so you just classify the variable into a few groups or into a few classification. Okay, but when you want to analyze this nominal data, so you have to see what is the modes, so that you know which one is the most preferred by your respondents. However, the mode is used less frequently compared to arithmetic mean and median. Why is that? Because it has some disadvantages. So the first disadvantages is that your data can have more than one mode. It is possible that people may love Lemo as well as Amor. It is possible maybe you can have three mode as well. Okay, and sometimes there is a possibility that you may not find any modes because the value may appear only once. Means that when you have so many data, so you cannot see the most frequently occurred in your data. So you don't have any modes at all. So that's why many researchers prefer to use medians or arithmetic mean compared to the mode. Okay. So this slide just want to present to you the positions of mean, medians and mode. So in a normal condition, when you have a symmetric distribution, in this case, you will have such a very nice bell curve shape. So your mean, medians and mode will be in the middle. So when you are dealing with the extreme large or small values, your mean will be affected and it will not be reliable. So if you look at here, the mode, medians are not affected. So what is mode? Mode is the most frequently occurred. So you can see that the mode is correct. Median is the middle value after you have ranked from the smallest to largest. So median is also correct. The same with here. So you can see that the mode is the most frequently occurred. So it will be on the right side. And the median is in the middle. But let's see what happened to your mean. Your mean will change because it is affected by the extreme values. And in this case, your mean will also be affected, right? So you can see that if let's say you are dealing with the extreme large or small values, you shouldn't use mean because mean will not be the good representative of your data. Okay? The next measure of location is called as weighted mean. So what is weighted mean? Is there any difference between weighted and arithmetic mean? You will find it later. So weighted mean is actually found by multiplying each observation, which is your x in statistic, by its corresponding weight, or we call it W. So let's look at the formula. So you have x bar. What is x bar? X bar is your sample mean. So x bar with small w. So you have this weighted mean equals to weighted 1 multiplied with x, your observation 1, plus second weight multiplied with its own observation and so on. And you have to divide it with all the weight. Okay, so if you look at this formula, it may look quite complicated, but I can make your life easier. So if I want to write the formula in a simple way, so I will put here x bar w. So weighted mean equals to summations of your weight multiplied with your observation over summations of all your weight. So this is the shortcut formula, but basically they are the same. So let's look at the examples on how to understand this weighted mean. Okay, so Carter Construction Company pays its hourly employees $16.5, $19, and $25 per hour. There are actually 26 hourly employees. So what is 26 employees here? So it is your weight. Okay, remember this is your weight. So 14 are paid at 16.5. So this is your first weight. And then 10, this is your second weight at $19, right? And 2, this is your third weight. So 2 at the $25 rate. So the question is, what is the mean hourly rate paid for these 26 employees? Okay, so basically if you look at here, 26 here is the total weight, summations of your weight. Okay, you can just simply put 26 here. Okay, so now how to find the weight? It is very simple. So you have to take the weight 1 multiply with 16.5. So 16.5 here is your first x, x1. So 14 multiply with 16.5 and then 10, which is your second weight, multiply with $19 plus 2 multiply with $25. So this is how to compute it. And then you divide it with summations of your weight, which is 26. You should get 18 point something dollars. Okay? This is another examples on how to compute the weighted mean. Okay, so there are actually three types of soft drink. You have the small size with the price of $0.5, mediums $1, large 1.5. So what is this price? 0.5. So this is your observation. So x1, $1 is your x2 and 1.5 is your x3. So you observe that this is the price for the soft drink. So 5 soft drink was sold. So what is this 5? So 5 is basically your total weight. Okay, so 5 soft drink was sold. 2 people bought small. So what is this 2? 2 is your first weight. And then 2 people bought medium. So this is your second weight and 1 person bought the large size. So this is your third weight. So you are asked to compute the mean using arithmetic formula as well as the weighted mean formula. Okay, so let's attempt to do the first one, arithmetic mean. So do you still remember what is the formula of arithmetic mean? Summations of your x over your n, right? Okay, so you have to sum all your observation. So the first observation, it says that 2 people bought small size. So the small size price is 0.5. So you have 2 persons, right? First person and second one. Okay, so you have 0.5 plus 0.5. I forgot to put the plus sign there. And then you have 2 people also bought medium. So medium with the price of $1. So you have $1 here, $1 here. And the last one person bought the large size and you have to plus 1.5. So sum all of this observation, you have to divide it with the n, which is 5. So you will get 0.9. Okay, so this is your arithmetic mean. So how to compute it using your weighted mean? Okay, remember, you have to, what is the formula of weighted mean? Summations of what? Your weighted multiply with your observation over summations of your weight. So summations of your weight, you know that you have 5 soft drink. Okay, so you have to take your weight, multiply with its corresponding x or observation. So your first weight, where is the first weight? We have 2, right? So 2 multiply with the x, 0.5. And then you have to plus because we are talking about summation. Plus second, which is 2 as well. So you have weight number 2 is 2 medium. So 2 multiply with this price, which is $1, plus second, the third weight is 1 person multiply with the price of the large size, which is 1.5. So when you divide it, you have to divide with the summations of weight, which is 5 soft drink. Your answer is 0.9. So based on this working, can you tell the difference between arithmetic mean and weighted mean? If you look at the answer are exactly the same. But if you look at the working, they have different formula. So you're going to have different working, even though your answer will be the same. Okay? Make sure that you know how to differentiate between the formula. Geometric mean can be used to find the average change of percentage, ratios, or growth rate. So what is this geometric mean? So it is the n root of the products of n positive values. Wow. Basically, this is just the interpretations of the formula here. So geometric mean is the n roots of all positive value. Okay. So it is also can be used to find the rate of change from one period to another. If let's say you are talking about this, so you have to use this formula. The formula is the n roots of value at the ends of the periods over the value at the beginnings or the starts of the period minus 1. Okay, so we will look at the examples later on and on how to apply this formula. Okay, so let's apply the previous two formulas in this question. Okay, suppose you receive a 5% increase in income this year and a 15% increase next year. What is the average annual percent increase? So you want to know the average annual percent change. So what is the first formula of geometric mean? So your formula is that you have square root of n of positive values. So you can have x1 multiply with x2 multiply with x3 and so on. So in this case, what is n? n is the number of years. How many years are you talking about in this question? You are talking about this year as well as next year. So your n is equals to 2. Okay, so you have to put square root. Okay, let me tell you the information, this information. For geometric mean, 1 is the original value. If let's say you have an increase of 5%, so you will write it as 1.05. If let's say you have an increase of 30%, so your value is 1.30. What if let's say you have an increase of 90%? 1.90. So in this case, in this year, your increase of income is 5%. So you will write it as 1.05. While next year, the increase in income is 15%. So you will write it as 1.15. So just take this number and put it in your calculator. You will get the answer or the value of 1.09886. Okay, next, you have to minus with 1. Why is that? Because this value is the value of increase. So if you want to see the changes, you have to minus 1. 1 is the original income, the original value. If you don't minus with 1, you cannot see the changes, the difference with the original value. So you minus with 1, so you will get 0.099 something. Okay, so this is the answer. But why do I multiply with 100? Because the question asks you about percent. Okay, so we are talking about percentage. That's why you have to multiply with 100. If let's say the question just asks you what is the average annual increase or annual change without any percentage here mentioned to you, so you don't have to multiply with 100. Because the question asks you about percentage, that's why you have to multiply with 100. Okay, so this is the applicable or the applications of the first formula of geometric mean. So let's look at the second examples of geometric mean using the second formula. Okay, so Los Angeles population increased from 258,000 plus in 1990 to 500 something in 2011. So the question is, what is the average annual percent increase? When we talk about percent, remember what should you do? At the end of your answer, you have to multiply with 100 because you are talking about percent. If let's say the question doesn't ask you about percentage, so you don't have to multiply with 100. Okay, so what is the formula for the second geometric mean? The formula is you have the square root of n, and then you have to take the value of n period. So this is the value of n period over the value of the start period. Okay, and then you have to minus 1. So this is the formula for the second geometric mean. So let's look at the example here. So what is the n just now? N is the number of year. So you have 1990 until 2011. How many years? So basically 1990 to 2011, you are talking about 21 years. So definitely your n is 21. Oh, I forgot. So this is 21, not 2 years, 21. Okay, so you can change it by yourself. So 21, the square root of, so you have to take the n, the value of the n period. So which one is the n, 1990 or 2001? Definitely 2001. So what is the value? The value is, where is it, my marker? The value is 500. So where is 500? 500. So 584,000 over the value of the start period. The start period is 1990. So over 200 something. Okay. And later on you have to minus with 1. Okay. So when you do this, you compute this, you will get the value of 0.0397. And then you multiply with 100 because this question asks you about percentage. If the percentage is not mentioned here, this will be your final answer. Okay, so but this question asks you about percentage, so you multiply with 100, so you get the value of 3.97%. Okay. At this stage, we have covered all measures of location. So in this slide, we will be focusing on measures of dispersion. So what is dispersion? Dispersion is the variations or spread in your datasets. So why do you think we have to study the dispersion? So there are actually many reasons why do we have to study dispersion, but I will just give you two reasons. The first reason is that if let's say your dispersions or your variation in your dataset is small, it means that your mean is representative of your dataset. But if let's say your variations or dispersion is large, your mean is not reliable. So you don't want to have that. So when we talk about dispersion or variation, you can consider it as making error or your error. So you want to have a small error rather than having a big error, because if you have a big error, means that your calculation is less accurate. Okay, the second reason why do we have to study dispersion? Sometimes you want to compare the spreads in two or more distribution. For instance, you have this dataset, okay, and you also have this dataset. Okay, so this is dataset A, while this is dataset B. So in dataset A, you can see the variation is this large, while in B, you can have this small variation. So if you are asked to choose which dataset do you prefer to choose? So definitely you want to have the smaller dispersion. Definitely B is your answer. You don't want to have large dispersion, because dispersion means or variation means you are making large error. So you will choose B over A. Okay. So in dispersion, we gonna have a few methods. The first one, we gonna have range, and we can also have variance, and the last one, we can also learn standard deviation. So range is the simplest forms of dispersion. So what is range? Range is the difference between the maximum values and minimum values. So if you look at the formula of range, it is very simple. How to compute the range? Your maximum values minus the minimum values. As simple as that. So let's look at the characteristics of your range. The first one, only two values are used in your calculation, which is your maximum values minus minimum values. In the case of your arithmetic mean, if let's say you have 10 observations, you have to take all the 10 observations in your calculation. But in the case of range, you will not take all the numbers. You will just take the maximum and the minimum. Okay. Second point to tell you about the characteristics of range, it is influenced by the extreme values, because you are taking the maximum minus the minimum. So this is very similar to your arithmetic mean. And the last one, range is easy to compute and easy to be understood by everyone. Okay? Since range can be affected by extreme values, so many people love to use variance. So let's look at the formula of variance. So in this case, we talk about population variance. Okay, so variance can be represented with sigma squared. Okay, if you don't have the squared, you call it standard deviation. Okay, so sigma squared equals to summations of x. So what is this x? X here is your observation minus mu. So what is this mu? Mu is population mean. Okay, squared over capital N, because we are talking about population variance. So definitely you are talking about population mean and capital N for population. Okay, so let's see what is the characteristics of your variance. Normally all observation or all x are used in your calculation. You will take into account all numbers. Okay. In the range, you will just take two numbers, but in variance, you will take all the numbers that you have. If let's say you want to compute 1000 numbers, so if let's say you want to use variance, you have to compute all the 1000 numbers. However, for the variance, the units that you get after computing this variance somehow difficult to work with, because when you compute it, the unit will be in squared. So sometimes people think that it is hard when they compute it, and then the answer is 2 squared. Okay, if let's say you compute this and then you got 2, and then you have also squared values here, which is somehow kind of weird. Okay, if you have a population variance, you should also have a simple variance. So population variance is represented by sigma squared, while sample variance is represented by S squared. But the formula are very similar. So it is equals to summations of x. X is your observation minus your x bar. So remember, for the population variance, you have mu because you are talking about population. But because we are talking about sample variance, so you have to use sample mean, which is x bar squared over n. So this is a small n for sample minus 1. So in the formula for population variance, you don't have this minus 1. But for the sample variance, you have to minus 1. Okay, so this is just the formula. Let's look at the examples of sample variance. Okay, the hourly wages for a samples of 5 part-time employees at Home Depot are $12, 20, 16, 18, and 19. So this is your observation or your X. Okay, so what is the sample variance? So if the question asks you to compute the sample variance, the first steps that you have to do, you have to compute the sample mean. Why is that? Because in the sample variance formula, if you look at here, you have the parts to compute, parts to compute the sample mean. So let's start with the sample mean. So how to compute the sample mean? So summations of x over n. So what is your x here? 12, right? So 12 plus 20 plus 16 plus what? 18 plus 19 over how many sample? You have 5. So you will get $17 as the answer. Okay, now you have computed the sample mean. The next steps, you can compute the sample variance. So what is the formula of sample variance? Summations of x. X is your observation. So 12 is the first observation. 12 minus your mean. Mean is 17 squared, right? And then plus the second observation, which is 20 minus your mean 17. Well, maybe I think it's better for me to write it, right? So that you can see it better. Okay, so you have the first x, which is 12 minus your mean. What is the mean? 17. So you have squared plus second observation, 20 minus 17 squared plus 16 minus 17 squared plus so on. And then you have to divide it with n minus 1. Your n is 5. 5 minus 1 is 4. So basically you will get the answer of 10 value. But because we are talking about variance, so it is not just 10, it will be 10 in dollar squared. So all your answer will be in the units of squared. That's why many people don't like it. They feel like it is hard to interpret your answer. So because of this weakness, most of the people or most of the researchers will love to use the other method, which is standard deviation. Okay? If you look at the formula for standard deviations, it is just the square roots of your variance. All the items in the formula are the same with your variance. Characteristics of your standard deviation. It is in the same unit as the original data. If let's say your original data in the form of dollar, so when you compute your standard deviation, you should also get it in the form of dollar. It is the square root of your variance. And the value cannot be negative. If you look at the formula, you will have this square root. So when you compute the standard deviation, you will definitely have a positive value. And the last point, it is the most widely used measure of dispersion. You know that range as well as variance have their own weaknesses. Because of that, many researchers love to use standard deviation as a measure of dispersions or variation. Okay, so let's look at the examples to understand standard deviation better. Standard deviations of investment in company A, let's assume that it is about $7.5, while the standard deviation in company B is about $10.5. So let's assume that the means of these two companies are about the same. So it means that the investment in company A is not dispersed as much as company B. Okay, so what does it mean? In other words, the value is close to the mean or the data are more reliable, because if you have large standard deviation, you know that standard deviation is a measure of dispersion. So if you have large dispersion, it means that the data or the means of the observation are scattered around the mean, or you can say that you are making more error or large error. So you don't want to have large standard deviation. You want to have a smaller standard deviation so that your calculation is more accurate. We can also use standard deviation to describe a distribution. So the Russian mathematician known as Chebyshev has actually developed a theorem that can allow us to determine the minimum proportions of values that lie within a specific number of standard deviations of the mean. Okay, for instance, let's consider the standard deviation is equal to 2. So according to the Chebyshev theorem, the formula is this one. 1 minus 1 over k squared. So k here is actually your standard deviation. Since your standard deviation is 2, so you just have to replace k with 2. When you compute this, you will get the value of 0.75. So how can you interpret this value? You will say a minimum of 75% of values lie within the mean. So this theorem can also be used regardless of the shape of your distribution. This is the examples of question for Chebyshev theorem. The arithmetic biweekly mean amount contributed by the Dupree-Pen employees to the company's profit-sharing plan is about $51, and the standard deviation is $7.51. So at least what percent of the contribution lie within plus 3.5 standard deviation and minus 3.5 standard deviations of the mean? So you want to know at least what percent of the contribution lie within this plus minus 3.5 standard deviation. So we can just apply the formula of Chebyshev. What is the formula? So this is the formula. 1 minus 1 over k squared. So k, as I told you earlier, refers to your standard deviation. So your standard deviation here is plus minus 3.5. So just replace k with 3.5. So by computing this, your answer should be 0.92, because we are talking about percentage. What percent of the contribution, right? So time this answer with 100. So you will get about 92%. However, if let's say your data or your distribution is symmetrical, so normally you are going to use empirical instead of Chebyshev theorem, because empirical rule will give you an accurate result. So what does it say? According to empirical rule, for a symmetrical bell-shaped frequency distribution, approximately 68% of the observation will lie within plus minus 1 standard deviations of the mean. So if you look at this shape or this diagram, you can see that this diagram is symmetric, right? Symmetric means that it has a mirror image. Your left side and as well as your right side should be the same. Okay, so if you look at this area, basically this area is 60% of your observation, and it is lie within minus 1 and plus 1 of your standard deviation. And empirical rule also says that about 95% of your observation will lie within plus minus 2 standard deviation. So if you look at here, 95%, it is starting from this area. So 95% of your observation here will lie within minus 2 and plus 2 standard deviation. And last, almost all, which is 99.7% of your observation, will lie within plus minus 3 standard deviation. So 99.7 is this area. Okay, this whole area is actually within minus 3 and plus 3 standard deviation. Okay. Sample means of group data. As I have mentioned in the previous slide, this part will not be covered, so you can just ignore these notes. Okay. I will skip this part as well, so you don't have to look at it. Ethics and reporting your result. So basically, it is very useful for you to know the advantages and disadvantages of mean, medians, modes, and other methods when you want to report the statistics to make your decision. And it is also important for you to maintain an independent and principled point of view. And last one, statistical reporting basically requires objective and honest communications when you come out with your result. Okay. So far in chapter 3, we have learned the numerical measures to describe our data. So under numerical measures, we have measures of location and measures of dispersion. However, somehow you can also describe your data using the shape. So shape is basically in chapter 4. Okay, so if you can see here, you have 4 different shapes of your distribution. So let's look at the first one. You have symmetrical distribution. Okay, when we said symmetrical, it means that you have a mirror image. Okay, so the mean, medians are all equal together with the modes. Okay, so can you explain why do you have this symmetrical distribution? So the example is age of a citizen. So normally we will assume that we're gonna have a low birth rate. So you're gonna have low birth rate here, and we're gonna also expect that you're gonna have low death rate. Right, so in the middle is somehow the majority of the population with the age of perhaps 45 to 50. Okay, so this is the symmetrical distribution. You can also have positively skewed distribution. It means that your distribution will somehow skewed to the right. Okay, when will you have this kind of distribution? Let's say we talk about salary. So majority of people will have the salary of very small amounts of money, maybe 3,000. So many workers will earn this 3,000 income. However, there are a very little number of people who will get such a very high income. So who are they? Like the CEO, your boss, and the top management people. Okay, so you're gonna have this kind of shape. We call it positively skewed distribution. Somehow, you can also have the third scenario. We call it negatively skewed distribution. So what is the scenario? So it is like your test score or your quiz result. So mostly many people will get a very good score. So most of you will get A or A minus. Very little number of students will fail, right? Sometimes you can also have such a very kind of weird or strange shape. You can have two peaks or maybe more than two peaks. We call it bimodal. So when will you have this kind of shape? So when we talk about two different data or three different data set, perhaps you are talking about or you want to study about people in one country where there are actually many groups of poor people. So where is it? So you have very many people which is coming from poor income group, and you also have many people who are coming from rich income groups. So when you have two different data set, you're going to have this kind of shape. We call it bimodal. Okay. How do you want to know whether your distribution is symmetric or not symmetric? So normally we can use skewness. Skewness is a measure of the symmetry of your distribution. There are actually two formulas to compute the skewness coefficient. However, in this course, we will just learn Pearson coefficient of skewness. So this is the formula for Pearson coefficient. So Sk is skewness equals to 3 multiplied with x bar. Remember what is x bar? This is your sample mean. So x bar minus median over small s. So what is s? This is your sample standard deviation. Okay, so when you have computed this, if let's say you got the result, so this is how you want to read the result. So the coefficients of skewness can range from minus 3 until plus 3. Okay, if let's say you got your result which is close to negative 3, it indicates that you have a considerable negative skewness because the maximum value of negative is minus 3. So if you got minus 3, you can say you have a negative skewness. If let's say you got the value of 1.63, you can say that you have a positive skewness. If let's say when you compute the skewness coefficient, then you got the value of 0. It means that your distribution is symmetrical. Okay? So this is the examples of question for skewness. Following table are the earning per share for samples of 15 software companies for the year 2016. So the earning per share are arranged from smallest to largest. So you have how many shares, how many earning? You have about 15. So the question will ask you, find the coefficients of skewness, and what do you conclude about the shape of your distribution? Okay, so how to answer this question? Let's look at the next slide. Okay. If you want to compute the skewness, so what is the formula of skewness? So you have Sk equals to 3 multiply with x bar, which is your sample mean, minus median over your standard deviations of your sample. Okay, so the first step that you have to do to find the skewness, you have to compute the mean, right? Because you have x bar here. So you have to compute the mean. So what is the formula for mean? Summations of x over n. So you have to sum all the 15 software and divide it with the number of software, which is 15. So you should get the mean is equals to 4.95. And then you can start computing the standard deviation, or you can also start with finding the median. It's up to you. Okay, so basically your standard deviation here is your sample standard deviation. That's why you have n minus 1. Okay, so by applying this formula, you should get the value of 5.22 for your standard deviation. And the median, how to compute the medians? You have to arrange from the smallest to largest, and then you have to take the middle point. So you should get the value of 3.18. So you have to practice this at home. And lastly, after you have all these components, you can compute the mean, median, and standard deviation. Then you can just plug in all this value into the formula of skewness. So by plugging all these values or information, you should get your skewness is 1.017. Okay, so the second question, what do you conclude about the shape of the distribution? So what will you say about your shape of distribution? Is it symmetric? Is it non-symmetric? Is it positively skewed, negatively skewed? So how can you interpret this? So you can say this shape of distribution indicates moderate positive skewness in the earnings per share. Okay, you can say you have 1.017. So this is a positive number, positive value. So you can say you have a positive skewness. If let's say this is negative 1, so you can say you have a negative skewness. If let's say you got 0.01, so you can say that you have a symmetrical distribution. Okay.